Thanks for joining us for today's office hours session on how to run disaster recovery and zone redundancy tests with Gremlin. Some quick notes before we get started. Again, this is an interactive webinar. We want to hear from you just as much as you want to hear from us. So again, feel free to use that chat window. Feel free to enter your questions in the Q&A panel or just say hi, and we'll be sure to get back to them after the presentation. This webinar will also be recorded, and the recording will be made available after the webinar. You can always check out our past recordings and future sessions at gremlin.com/. This is a monthly series, so we'll be presenting a new topic every month. And also, I'm Andre Newman, Senior Reliability Specialist here at Gremlin, and I'm joined by Dan Muret, who is a Senior Solutions Architect also here at Gremlin. Again, we're here to answer your questions and to basically to answer any questions you might have about this topic, so feel free to enter them. So quick overview of how today is going to go. I'll start with a short presentation introducing the topic. Dan will run through a demo showing you how to actually use Gremlin to test zone redundancy and how to recreate zone outages. We'll leave time at the end for open Q&A. Again, you can drop those questions into the chat or the Q&A panel and we will get to them. We'll also be able to unmute yourself during the Q&A session. So if you'd like to ask a question out loud, feel free to do so as well. So if you've been to sessions before, you know I like to set some goals just to sort of stage what we're going to be going over through today. So let's do that. So looking ahead a bit, Dan has an AWS environment set up where he's going to show how zone redundancy testing works. So with that type of an environment in mind, let's say we have two EC2 instances set up behind a load balancer. When testing zone redundancy, we want to make sure that, for one, they're running in separate availability zones. And more importantly, we want to make sure that our load balancer is correctly set up to route traffic between the zones. So if one instance is unhealthy, if one AZ is down, we can route traffic to the healthy one. That way, we just know that our service can keep running and our users can keep using the service with zero interruptions and zero noticeable impact. If you have any goals of your own, if you have any projects that brought you to this session or things that are top of mind for you and your organization, we want to hear about it. Let us know. Let us know what you're working on that's related to zone redundancy or what got you interested in this topic. So let's just start out with some baseline definitions, some level setting. When we say zone redundancy, what we're really saying is availability zones, or AZs. When you're using a cloud platform like Azure or AWS, the platform's infrastructure is split into different regions, and each region has several AZs beneath it. Think of it kind of like a single standalone data center. It's a location where you can provision your resources, like your computing instances or Kubernetes clusters and serverless functions. But it also serves another really important purpose. And the key idea behind an AZ is that it's isolated. So if one AZ fails, then the other AZs will keep running and not be impacted by the failure. So if there's a fire or a power outage or a poor engineer has a finger slip and they send out the wrong command, it shouldn't impact any other AZs, just the one where the incident happened. In practice, an AZ can be multiple data centers or even a single data center that's like partitioned into multiple different zones, but logically, the idea is that they're independent standalone units. And even though these AZs are isolated from each other, they're still connected over high-speed networks. So you can have, let's say, two compute instances and two separate AZs and have them connected over the same virtual private cloud network. For all intents and purposes, it's no different than having them on the same rack. That's kind of the magic of the cloud. So this is what makes zone redundancy possible, right? This ability to fail over quickly and seamlessly just by essentially redirecting network traffic from one destination to another. Now let's kind of take this a step up a bit towards disaster recovery. Now, disaster recovery is when a failure happens that impacts workloads and we need to take manual action to restore service. So our failover process, for whatever reason, doesn't work. We need to go in and jump in and fix it ourselves. So imagine that, we have our zone outage, but instead of our load balancer being able to kick in automatically and redirect traffic, our users start seeing error messages, or even worse, let's say the second AZ gets all that load that was going to the first AZ and buckles because it can't handle it or it's unable to scale up. And as anyone who's ever done disaster recovery knows, it's a very complex topic with a lot of moving parts. But if we boil it down to its essentials, there are basically three major steps. First is your inciting incident. This can be your power failure, your data center flood, or even, the engineer who accidentally sent a command with an extra space in it. Doesn't matter what, as long as it results in an outage, it still counts. The first thing engineers typically do is detection. Ideally, you'll have an observability tool set up that will notify you of this instance, but sometimes it's a person who is just watching logs or watching metrics or is using your application and notices that something's not quite right. Ideally, it's somebody in your company. Ideally, it's an engineer, but worst case scenario, it's a customer and you get that notification through your support team or what have you. The important thing is that the outage is seen and raised with the engineering on-call team. Next, typically, the on-call team springs into action to declare an incident, set up communication channels, and bring in subject matter experts. Then after some troubleshooting and fast typing and a lot of really smart people knocking heads together, they're able to fix the issue and start restoring service along with any data that might have been lost. So why am I talking about zone redundancy and disaster recovery and all the stuff that goes into it? Well, these are all old topics. They're not anything new, but they kind of went through these massive shifts when cloud computing became more popular. It used to be that if a data center went down, it was your responsibility to get it up and running again. Now, if a data center goes down, it's your cloud provider's responsibility. Is one thing that has kind of stayed consistent though, and that's the fact that whoever's using your application, your customers, if they find out your service is down, they're going to complain. So the goal here is to ideally eliminate that potential downtime that's caused by these zone failures. And if we can't do that, then reduce the time to recovery as much as possible. The great thing is that major cloud providers like AWS give you the tools to be redundant, or at least the basic building blocks, the foundations. So for example, we can deploy EC2 instances to multiple different zones. We can spin up a Kubernetes cluster and have our worker nodes be automatically and intelligently distributed across different zones for redundancy. And we can start a load balancer, elastic load balancer, or ELB, that's completely separate, that just routes traffic from one computing instance to another, regardless of zone or region. Now, you might not have direct visibility into how these tools work or what they're doing, under the hood, but they are available. And it's up to you to connect them in the right way to get them working. This does kind of present a problem, though. Once you've built these redundancy and failover systems, once you've had this, really intricate and complex ability to redirect traffic, how do you actually make sure that it works? You can't exactly ask your cloud provider to take down a region or zone for a short amount of time. And, I don't know about you, but I don't want to wait around for the next AZ failure to happen in my cloud provider. So there's ideally got to be another way for us to be able to test these systems under, controlled conditions. And that's really where Gremlin comes in. Instead of us trying to, or us having to wait for an incident to happen and having to respond like in a disaster recovery scenario, we take a more proactive approach. We simulate these large-scale outages ourselves by running a test. So instead of the big red X that you saw on the last slide, we just use Gremlin to temporarily block traffic from one or more AZs. And using that system, we make sure that we can still communicate with our service and that still load bounces over to the other AZ. And really the key benefit here is control. Using a tool like Gremlin, you have full control over the failure, including which AZs or regions you target, how long this test runs for, and most importantly, you can stop and reverse its impacts instantly. It's not just a technical thing that we're doing with Gremlin, it's also a people and processes thing. So you can imagine that while you're running a test and one of your zones is down, you're able to pull out your disaster recovery playbooks and make sure that the step-by-step processes work. You can have a chance to go through them, to try them out, to try and restore service. So it's a way for you to test these types of outages on a large scale while giving you the control to back off if you need to, and also being able to test both your technical and your people processes. And one last thing I wanted to cover before the demo is, for folks who've been using Gremlin for a while, you probably know about scenarios. For those who don't, scenario is a workflow where you can run multiple experiments in sequence or at the same time. We try to build a bunch of scenarios into Gremlin just based off of cloud best practices. And one of them is the one that you see on screen, this region evacuation scenario. This one has 2 steps in it, as you can see. It takes one availability zone down for 1 minute. And the next step is it takes an entire region down for a minute. And when I say down, obviously it doesn't actually take the region down for everybody. It just drops network connectivity to and from your host so they appear offline. So while this test is running, you can check your services to make sure they're failed over properly. Gremlin has a built-in tool called a health check that can automatically monitor these services for you using your existing observability tools. The health check is also able to stop the scenario. So if it's running and your failover process doesn't work correctly, the health check will detect that and then roll it back. And if you want to take this a step further, you can schedule the scenario or import it into a test suite so it runs regularly. And the big benefit to this is that if you introduce any regressions or you have any changes that might cause your failover process to not work the way you expected or to change, having a regularly scheduled scenario will catch that and can raise that. And it will keep that history of pass and fail results so that you can go back and double check and make sure that your services are still reliable. And so with that, I'm going to hand it over to Dan, who will show us how this works in action.
All right, let me start sharing here and then we'll jump into it. All right, so starting out, thought I'd show real quick the AWS setup. So this is the load balancer I've got set up. So this is a load balancer. We can see that it is looking at making sure that that is healthy. And my two targets here are the two EC2 instances that I have built, configured with a simple web server. We'll look real quick at the two instances. So I've got two different Linux EC2 instances here. These are basically just running a simple Nginx web server that will display the IP address. Biggest thing here, we can see that they are in two different AZ. So I got US West 2A and 2B here. So going to the load balancer URL, if I look at this, as I refresh this, we'll see that the load automatically switches between the two hosts. So we can see the IP address here changing from 36 to .22. So this is basically just showing that the load balancer is working. We're able to hit both targets in both AZs. So let's go ahead and jump into and create the AZ failure. So easiest way to do this or to show this is simply through an experiment. This also is a test that's ran as part of services, if you're familiar with services in Gremlin. But for this, we'll just do a simple experiment. So host, right away, you choose the host to target. So Gremlin makes this pretty easy. We pull in the different zone tags from the agents. So we can see those same two agents having the 2B and 2A availability zone. So I can easily just select the zone I want to simulate the failure on here. This is basically going to block traffic to this machine. I can also do this by just selecting just maybe the entire environment, or just going down and then selecting the AZ tag through the configuration of the black hole experiment. Those are all listed here. So this is the same basic tag that we use. So we'll go ahead, we're going to select the AZ zone, or the AZ. We'll go with 2A. So we're going to basically simulate a zone failure on US West 2A for these EC2 instances and make sure that our website stays up and we're able to hit that. So we're going to choose black hole. For this, the default should be fine. Of course, this is just going to run it for a minute, but if this was a real DR exercise, maybe you needed to run this for 4 hours, so you could increase that time, that sort of thing. We can also exclude different IP addresses, host names, very similar to a typical black hole experiment. So we're going to kick this off. This will take, of course, just a second to set up and start running, and we will give it just a minute. All right, it says it started, so we should get logs here in just a second. We'll take a peek at those. All right, so the black hole is set up, so we're basically simulating that AZ failure now. So we can see the changes that we've made to the adapters on this system. So if I go back now and look at my load balancer again, if I hit refresh a few times, we should see that I'm constantly getting a reply back from this IP address that's no longer switching back and forth between the two different systems. So this is, of course, a very simplified approach to this. We're just basically pointing at a couple of Nginx servers that are, giving us an IP address. So this does show that the application is still available. And typically AWS lags a little bit. Sometimes you can come back in here and catch, and you'll see this actually go unhealthy. So we'll actually see this because AWS is connecting to port 80. Since it can't connect, this will eventually refresh if it goes on long enough and be able to show that status here. But the biggest thing is making sure that my application is still available. So I'm still able to hit my website. So, kind of shows that even though that AZ has failed, we are now able to still connect to our application. And we'll see that continue through the process. And then the experiment will wrap up. Actually, it looks like it's beginning to wrap up now. So that should allow us to go ahead and continue back on. Sometimes it takes a second for the load balancer to catch up and start rerouting traffic back to the other AZ as well. That is it for the quick and dirty demo on the AZ failures.
Cool. Thanks, Dan. Let me switch back to my screen so we can just wrap up. So while we wait for a few more questions to roll in, just a few final thoughts. If you want to try this out for yourself, just to start running your own zone redundancy tests or do your own disaster recovery planning, if you'd like to do that, there's an easy way to get started. If you're already a Gremlin customer, just sign into your account, head over to scenarios or experiments, and you can configure a black hole experiment from there. We also have in our recommended scenarios a zone redundancy test already built and ready to go. All you need to do is configure it by pointing it to your AZ where your systems are running, or the AZ that you want to test, and just click run. If not, you can sign up for a free trial by going to gremlin.com/trial. And again, if you found this session useful, we'd love to see you at a future session. We post all of them that we have planned, including the topics that we're going to talk about at gremlin.com. They're all free. They're all open, just like this one. All you need to do is sign up and we'll save you a seat for you and send you a reminder. And we also have our previous recordings posted there too, in case you want to go back and watch those. And I'd highly recommend it. There are a lot of really good ones. So looks like we have a few questions already coming in. I'll start with the one that is in chat because that was in response to another question. The question is, can you explain how the experiment works? Dan, would you like to take that one?
Yeah, I kind of put that in there. So basically, Gremlin, when you install Gremlin, it has an agent. That agent has permissions to run different types of commands on the system. So for network experiments specifically, we use some Linux commands to adjust the quality of service. So we're doing things like adjusting for the black hole. We're just not allowing traffic to flow out to that. Looks like you're asking for services like RDS. So RDS is a little different. It's fully managed by AWS. So you don't have the ability to put an agent on like the RDS, whether it's DynamoDB or whatever service you're using. But what you can do is you install the Gremlin agent either on EC2 or an EKS cluster or something of that nature. And then you can block traffic or add latency to the connection to the RDS to simulate what happens if that RDS fails. And again, if you have a load balancer in front of the RDS, you can kind of simulate the same type of a thing just by blocking traffic to that. You can configure it a little bit differently. You would just put in the IP address or the target of the RDS that you're trying to connect to. And then you're able to simulate the same type of latency and failure for those services as well.
It's like another question just below that is asking essentially kind of more in detail, how does the black hole work? Does it update actual network rules to simulate down nodes and then revert the change? Does it have visibility of other monitors that showed something went down? How are we basically doing that and then detecting that it actually happened?
Yeah, so yeah, we're using network rules. The black hole, I believe, uses TC specifically. So that just basically it just changes the QoS, so basically blocks all traffic or drops all traffic going to the targets we specify. So we do those changes and then we revert those changes when the experiment ends or when you hit the halt button inside of Gremlin. So it stops it back. So the other part of that question, does it have Visibility of other monitors showed something went down. So yeah, it would be just from the perspective of where you're running the experiment from. So your other monitoring tools may or may not see that depending on how they're connecting and how they're monitoring the endpoint that you're blocking. But it is still a good way to simulate that outage or that scenario without actually impacting those AZs.
Oh, hope that answered your question. We had a few questions come in the Q&A panel. The first one is, we like to use OCI and we don't have multiple zones in most of the regions. In that case, how will that work? I'm personally not sure where OCI is. Dan, are you aware?
I'm guessing it's open container, but I'm not 100% sure.
Okay.
That's
Well,
what they're asking in that.
just to focus on the not having multiple zones, I guess.
Yeah.
In that case,
Could be
you
Oracle
can't really be
Cloud.
zone redundant if you don't have multiple zones. It's kind of a it's kind of a non-answer, but frankly, that's kind of just how it is. Um, the main thing behind this is that you want to make sure that for services that are critical that you really want to keep up, you have them running in at least two separate, fairly isolated spaces. So if your cloud platform doesn't call it a zone per se, but you have services running in two different regions or two different data centers or whatever it might be, that's effectively the same thing. And you would test it effectively the same way. You would just drop that traffic to one of those and make sure that you can fail over to the other one. But if you don't have multiple zones or if you're not replicated, then you're kind of unreliable, frankly. You should probably focus on getting those replicas spun up. Oh, it's Oracle Cloud Infrastructure. Okay, my mistake.
And that kind of brings up a good point. I mean, I'm not super familiar with Oracle Cloud. I assume they have something kind of similar to Zone. They may just call it something different. So it may be a different tag that you target. You can also simulate this even in an on-prem infrastructure, right? So basically all we're doing is looking for a tag that identifies this. So I've worked with customers to set this up. So they may put a tag in that has a row and a rack in a data center, and you can then target an entire rack to do a black hole experiment on to simulate that rack going down. So maybe it's a failure with the top of racks, network switch, or power supply issue, or whatever the case is. You can still use tags to do a lot of different scenarios in Gremlin, and that's really what we're doing under the covers with the black hole or the zone failure, is targeting a group of tags, blocking traffic to those to simulate those being down. So it looks like there's another question around a Kubernetes cluster with multiple nodes inside a region. So yeah, you can do the same thing. That was the other option that we had for demos for this, is to target a node in like EKS in my case. And you can kind of see, the pods, depending on how your deployment is set up. If you don't have like a daemon set, or you don't have your affinity, anti-affinity, all that good stuff set up properly, where you have pods running in on the different hosts, you can see that impact. You will also see that host go unhealthy. If you do like a kubectl get nodes, you'll see that the one that is being targeted as a failed node will go unhealthy. So you can definitely simulate the same type of activity, same type of testing inside of Kubernetes as well.
And one came in from Jackson. How do we validate that the zone we are attempting to run the black hole attack on is down? Dan actually showed that a bit when he showed how to start the attack in Gremlin. Essentially, when you start an attack, Gremlin spins it up, it brings you to the page where it's running, and you can track its progress there. We also have a little indicator in the top right corner of the screen that shows attacks in progress. So if you want to see if something's impacting a certain zone or a certain type of test is running, you can check there as well. What you won't be able to do is go to like your cloud provider platform and see if the attack is running or if the zone is down, because Gremlin's just impacting the connection between the host that you're running the attack on, or the Kubernetes container, whatever it might be, and that AZ. So you can most likely just go into Gremlin just to see if that attack is actively running. And then there's one from Angel. Do you have, oh, if I pronounced your name right, do you have any suggestions on how to do an AZ outage for a specific set of resources, like a couple of ECS clusters, RDS instances, and so on, without bringing down the entire AZ? So when you're setting up your attack in Gremlin, this also, Dan showed this a little bit during the demo too, you can pick and choose which resources you want to actually run it on. So kind of like you mentioned, if you only wanted to run on an ECS cluster, or a host that's talking to an RDS instance, you can use tags to select all of those at once, or you can just explicitly one by one select each of those. And that way you're only running the experiment on those specific nodes, and not everything that talks to that AZ. And a good one. Is there support for ECS Fargate? So we don't have full support for running all of the experiments that you saw on Fargate, but we do have another product that we call failure flags. And essentially what that is it's taking the reliability testing, chaos engineering principles you saw here and putting it into the application. So let's say instead of running a black hole experiment on a Kubernetes host or a container, you're going to run a similar experiment within the application itself. So you can target individual requests that are actually going through your application. So kind of translating this, what you could do is you can add failure flags to the application running within ECS, and you can run an experiment that says, for any requests going to or from this particular AZ, drop 100% of those requests. And essentially it will have the exact same impact. It's just done slightly differently. And failure flags is relatively new, but you can learn more about it by going to our docs. We have a bunch more information there. Or, of course, follow up with us afterwards, and we'll be happy to tell you more about it that way as well. A question on charge. Oh, or I guess it was just answered. Thanks, Dan. Appreciate it. All right. Just going back over to make sure I didn't miss anything. But if anybody has any other questions, definitely feel free to put them into the chat or Q&A panel. We'll be here for another minute or so just to see if any last minute ones come in. I guess we got all of them. Cool. I mean, these are all really good questions. Thanks all for being so engaged and for asking them. Again, we do these monthly. So if you'd like to see our future sessions, just head over to gremlin.com and feel free to sign up. If you do think of a question afterwards, after the webinar ends that you weren't able to ask, you can always reach out to us by going to gremlin.com/contact or by filling out the form after this webinar. Always happy to hear from folks. Always happy to hear about projects you're working on or things you need help with, or what brought you to learn more about reliability in the first place. So definitely keep in touch. Hope this session was useful for you all. We will have a recording that will be published shortly after this ends. So keep an eye and ear out for that. In the meantime, thanks so much for joining us, and hope you have a great rest of your week.